Welcome to session 3. The topic we'll be discussing in this session is MAC, Medium Access Control. So we'll be discussing why we need a specialized MAC for wireless networks. And then we'll be discussing several way of accessing the mediums, like several medium accessing techniques like SDMA, space division multiple access, FDMA, frequency division multiple access, and TDMA, time division multiple access. And then we will be discussing few types of fixed TDM, fixed time division multiplexing techniques. So that's what we'll be discussing in this session. So the learning objectives of this session is, at the end of this session, the learners will be able to understand the need for a specialized MAC for wireless communication and why the existing MAC from the wired networks cannot be used in wireless networks. What is the drawback of that? Why we need a specialized MAC, and what this specialized MAC, what features does it have? These things they'll be able to understand. And also the learners will be able to understand the working principle of space division multiple access, frequency division multiple access, and time division multiple access. And also they will be able to explain and they'll be able to describe how the fixed TDM like classical aloha, slotted aloha, CSMA, carrier sense multiple access, DAMA and PRMA techniques works. All these are various multiple access techniques. Okay, fine. So let us start with the motivation for a specialized MAC. Why we need a specialized MAC in wireless networks? So first let us try to understand, is it possible to use the existing MAC from the wired networks in wireless network? So in wired network, the commonly used MAC in IEEE 802.3 is CSMA-CD, which is carrier sense multiple access with collision detection. So how CSMA-CD works in the sense, if a sender want to send something, the sender will sense the medium. So in case of IEEE 802.3, it's a wired medium, that is the sender will sense the wire, whether it is free or not. If the medium is busy, the sender will wait until it becomes free. If the medium is free, the sender will start sending the data, and also at the same time he will be listening the medium. Why he is listening means because there should not be any collision by somebody else sending some other data through the same wire. So the sender will be also sensing the, while transmitting also he will be continuing to sense the medium. So at some point of time, if the sender detects a collision, he will stop sending and the sender will send a jamming signal, which means there is a collision and he is signaling the opponent party. Okay, so this is how CSMA-CD works, right? So in CSMA-CD, if the sender wants to send something, first he will sense the medium. If the medium is free, he will send the data, but at the same time he will also listen to the medium. Is there any collision happening or not? If there is a collision, immediately he will stop sending and he will be sending the jamming signal. If the medium is busy, then the sender will wait until it becomes free. So this is the overall concept. Now, why not we adopt this same technology to wireless networks? Okay. See, in CSMA-CD, the sender will try to detect the collision at the receiver end. So because the strength of the signal is almost same in the sender end also and also in the receiver end, because the signal is passing through a wire. And when the sender is trying to detect a collision at the receiver end, obviously he can also detect a collision at the sender end. So that is not a problem in a wired network, but that cannot be done in wireless networks, because as we know, the signal property, what happens in the sense, the strength of the signal will reduce in proportional to the square of the distance. So that is what the concept of inverse square law says. So CSMACD basically, it will fail in wireless networks because the sender cannot detect a collision at the receiver end, because the signal when it reaches the receiver, it will become it will become comparatively less in strength. So the sender who is sitting far away cannot detect a collision at the receiver end. So here what may happen in the sense, assume a sender, if CSMA CD, if we apply in wireless networks, then what will happen in the sense, says sender A is sending some data to another mobile station B. Okay, this data is reaching B. Now assume that some other station C is sending a data to B. Now when the data of C reaches B and when the data of A reaches B, there is a collision. But this collision cannot be sensed by A because the strength of the signal will reduce when it reaches the sender. So the sender's range also will be limited. So he cannot detect a collision of that distance. So the sender will assume that the data has been transmitted successfully, and then he will be start sending the next data packet. But actually that has not happened. There is a collision and the sender failed to detect the collision. So, so CSMACD will not work uh, in wireless networks. Okay. So this is the main problem with CSMACD. So we cannot use the existing CSMACD in the wireless network. So this is the need for a specialized MAC. Okay. So, so the basic problem is that in wireless network, this if a collision occurs in wireless network, the signal strength decreases in proportional to the square of the distance. Okay, the sender may apply carrier sense and detect an idle medium, and thinking that the middle medium is idle, the sender may start sending. But a collision happens at the receiver due to some other sender. Okay, so this collision cannot be detected by the sender. The sender detects no collision and assumes that the data has been transmitted without errors. But actually, there is a collision and the data got destroyed. So basically, collision detection becomes difficult in wireless networks, and because of this reason, we need a specialized MAC. Okay. So, so let us now understand how CSMA or CD fails in wireless networks with some examples. So whatever we have discussed, that was explained here. So sender A is sensing the medium and the medium is free. So he is sending the data and the medium is free. So he is sending a data to B. At the same time, C also want to send some data to B. He is also sensing the medium and the medium is free. So he is sending some data to B. Now there is a collision in B. Now sender cannot detect this collision because of the inverse square law. The signal strength decreases in proportion to the square of the distance. So to that distance, he cannot sense whether there is a collision or not. So the sender assumes that there is no collision and he starts sending the next packet. But actually there is a collision. But actually there is a collision. So this problem So this problem, so here the problem occurs because C is hidden to A and A is hidden to C. So this is called as hidden terminal problem. This is called as hidden terminal problem. So here basically CD fails, collision detection fails. Okay. So let us also discuss some other cases where this type of problems will occur. So first let us understand how the hidden and exposed terminal problem works. First let us see hidden terminal problem. If you apply the CSMACD in wireless networks, CSMACD is a technique which is used in wired network, that is IEEE 802.3. If we apply the same technique in wireless networks, then how it becomes a problem, let us try to understand. Okay, so here what happens in the sense, we have three mobile phones in such a way that A can reach B, but it cannot reach C. The transmission range of A can reach B, but it cannot reach C. The detection range also. A can detect any signal from B, but it cannot detect any signal from C. Similarly, C can reach B, but not A. That is, the transmission range of C goes up to B, and it also can detect signals from B. It cannot transmit to A, and also it cannot detect any signals from A. B can reach both A and C. B can reach both A and C. That is, the transmission range of B reaches A and also it reaches C. B can also detect from A and also it can detect from C. Okay. Now, now say for example, now say for example, A want to send some data to B. If A want to send some data to B, A will sense the carrier whether the carrier is free or not. So the carrier is free. If the carrier is free, A will send the data to B. Okay. Say at the same time, C also want to send something to B. So C also checks the carrier, senses the carrier. The carrier is free. So C will send some data to B. But there will be a collision at B because A is also transmitting at the same time. So this collision cannot be sensed by both A and C, and they will assume that their data has been reached successfully to B. So this problem is called as hidden terminal problem because here C is hidden to A and A is hidden to C. So this is one of the problem that will happen if this is one of the problem that will happen if same technique from wired networks if they are borrowed to wireless networks. That is, A sends to B, which C cannot receive. C wants to send to B, C senses a free medium, so CS fails. So collision at B. A cannot receive the collision, so CD fails. So here A is hidden for C, and C is also hidden for A. Okay, fine. So similarly, there is another problem which is called as exposed terminal problem. So what is exposed terminal problem? In exposed terminal problem, what happens in the sense, assume the same scenario, but here let us say B want to send something to A, and B senses the carrier, and the carrier is free. So B started sending something to A. Now C wants to send something to another terminal which is not A or B, maybe C, which is somewhere out of the transmission range of A and B. Okay, but but C is but C waits. C defers its transmission because C can sense B. So C is thinking that C is communicating to somebody else. Sorry, B is communicating. So C thinks that C is in the transmission range of B. So C thinks that B is communicating with somebody else. So let me not use the medium. That is, C is checking the carrier sense, and the medium is being used by C. So it is postponing or it is deferring its transmission. Okay, but actually C can start sending because C is sending to somebody else. So there will not be any collision because of that in B or A. Okay, so this problem is called as exposed terminal problem. Here, here C is unnecessarily deferring its transmission. C wants to send some data to some other node which is not A or B. But C senses the medium and the medium is getting used by B. So C thinks that B is using the medium. So if I send a data now, there may be a collision. So B is postponing or deferring its communication. But actually C need not postpone. So this problem is called as exposed terminal problem. Here C is exposed to B. Here C is exposed to B. Okay. Similarly, there can be another problem also with if we use the same technique, that is CSMACD, from wired network to wireless networks. So that problem is called as near and far terminal. So here let us assume this scenario. There are three mobile phones A, B and C, where B and C are placed close to each other, where B and C are placed close to each other and A is little further away. Okay. Here, here every node can reach every other node. That is, A's transmission range can go up to B and C, and B's transmission range, obviously it can go up to A and C, and C's transmission range also can go up to A and B, and their detection range also. That is, every mobile phone can reach every other mobile phone. And also here we are assuming that C is an orbiter. Orbiter in the sense C acts as a base station for coordinating the media access. It is who will be getting the media access at what time, that will be decided by C. That is, C temporarily acts as an orbiter. Okay. But here what happens in the sense the mobile phones are placed in such a way that B is close to C. B is close to C. Okay. Now A and B, let us assume A and B having the same transmission power. Okay. Now what happens in the sense, if A sends anything to C, if A sends anything to C, that will be drained by B. Because when A sends something to C, by the time it reaches B itself, the signal will be low. And B itself will absorb some of the signal. B will drain out A signal, and C signal and A signal cannot reach C at all. Okay. C cannot receive A's transmission because B will drown out A, because B will drown out A most of the time. Now, C cannot apply a fair scheme for media access because it would only hear B. It cannot hear A at all. So this problem is called as near and far terminals. So B is near to C and A is far away from C. So the one who is near to C is draining out the energy and is not allowing the other person to communicate with the orbiter. This problem is called as near and far terminals. So this problem may also occur if you use the same CSMACD technique from wired network in wireless networks. So these are the reasons why we need a specialized MAC for wireless networks. So this is about the motivation for a specialized MAC. Right? Now let us understand a few medium access techniques. So let us start with SDMA, space division multiple access technique. Okay. So space division multiple access technique, it is used for allocating a separate space to users in wireless networks. Okay. So the so so the optimal case, so it is something like, one of the example is assigning an optimal base station to a mobile phone user. One of the example is to assign an optimal base station to a mobile phone user. That is, the mobile phone, MS means mobile station or mobile phone, may receive connection from several base stations. It may be able to connect with several base stations with different quality. And the MAC algorithm will decide which base station is the best base station based on frequency division multiplexing or time division multiplexing or code division multiplexing, whatever it is available. And that base station will be allocated for this mobile station. Okay, but nowhere space division multiplexing will be used in isolation. It will be used in it will be used along with any of the techniques like frequency division multiplexing, time division multiplexing, or code division multiplexing. Okay, and the basis for the space division multiplexing algorithm is it is formed by cells and sectorized antenna. Okay, this is how space division multiplexing, a multiple access technique works. So the next kind of multiple access that we'll be discussing is frequency division multiple access. So in pure frequency division multiple access, it changes frequencies according to certain pattern. Okay, so it changes frequencies according to a certain pattern. That is, uh, so FDMA. So but generally FDMA will be combined with CDMA. In many wireless systems, FDMA will be combined with CDMA uh, to avoid the problem called as narrowband interference. Okay, so with okay, so see there are two ways of applying FDMA. There are two ways of using FDMA. The first method is pure FDMA. The first method is pure FDMA. So what is pure FDMA? Pure FDMA means you fix certain frequencies for certain users and don't change at all. That is all, every time the user will be using the same frequency. The example is radio station. Here the example is radio station. So in radio station, what happens? Every time the user will be using the particular radio station will be always using the same frequency. The frequency will never change. Okay, so that is called as pure FDMA. And another form of FDMA is you can change the frequency according to certain pattern. According to certain pattern, maybe based on time. Okay, it is every day, morning 6 to 7. This particular frequency will be used by one particular station, and again morning 7 to 8 that frequency will be used by some other station. Okay, like that. So different, so here the frequencies will change. So there are two ways of using. One is pure FDMA. Pure FDMA means fix the frequency for different users and there will not be any change. Whereas in uh, there is another way which is not there is another way of using FDMA is change the frequencies according to certain pattern. So FDMA combined with TDMA is normally used in wireless systems to circumvent narrowband interference. Okay, so either FDMA is used with TDMA or uh, with, with 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 CDMA like other techniques. Okay, so here the sender and the receiver have to agree on the hopping pattern. Hopping pattern means how the frequency is getting changed. How the frequency is getting changed. So that is called as hopping pattern. Okay. So generally in wireless networks, the frequency will not be fixed for a particular user. Because if you fix the frequency for a particular user uh, permanently, then there will be a law. Then there will be a. It means we are not properly using the bandwidth. Okay, then the bandwidth is getting misused. So to avoid that problem, the sender and the receiver will change the frequencies during their communications. Okay, so that frequency, whatever the frequency in which the sender will communicate at different point of time, that will be known to the receiver, so that the receiver can also tune in to that particular frequency. So that concept is called as hopping pattern. That concept is called as hopping pattern. If the hopping pattern is not followed, the receiver could not tune to the right frequency. Okay. Hopping patterns are normally fixed for longer duration. Hopping patterns are normally fixed for longer duration. Because if you keep on change the hopping pattern, then also the sender and the receiver has to be coordinated. Again, the coordination or synchronization, it also becomes difficult. Okay. So, so hopping patterns are typically fixed for longer duration of time, and normally the FDMA uses duplex channel. That is, both the partners can send and receive at the same time. And the communication from the mobile station to base station and base station to mobile station are separated with different frequencies. These different frequencies will be used for communication from mobile station to base station, and different set of frequencies will be used for communicating from base station to mobile station. And both the parties should know the frequencies of frequencies in advance. The communication from mobile station to base station is called as uplink, and the communication from base station to mobile station is called as downlink. Whenever communication happens from mobile station to base station, that is called as uplink, and whenever communication happens from base station to mobile station, that is called as downlink. Okay. So so we can, let us consider this diagram. So here you can see there is a mobile station and also there is a base station. So this is the mobile station or mobile phone, and this is the base station or the tower. Okay, so base station is technically called as uh, tower is technically called as base station. So this is the base station, and these are the frequencies in which they are communicating. Okay, the communication from the base station to the mobile station is done using this frequency. Okay, and the communication from mobile station to base station is achieved through this frequency. The communication from the base station to the mobile station is called as downlink. I am representing as DL. The communication from the mobile station to the base station is called as uplink. I am calling it as UL. Okay. So these are the set of frequencies. These are the set of frequencies used for uplink. That is for communication from the mobile station to the base station. The frequency range is between 890.2 megahertz to 915 megahertz. And the communication from the base station to the mobile station, for that these range of frequencies were used. That is, for downlink, the set of frequencies used were from 935.2 megahertz to 960 megahertz. Okay. And the each channel has a bandwidth of 200 kilohertz each channel. So this is one channel. Okay, so one channel, the channel width is 200 kilohertz. Okay, if the download frequency is, sorry, if the upload frequency, let us consider the upload frequency. If the uplink frequency is 890 megahertz plus n point 2 megahertz. Okay, uplink means mobile station to base station. If the mobile station to base station, if that communication is going through this frequency 890 plus zero point 0.2 megahertz, okay, then the downlink frequency will be FU plus 45 megahertz. Okay, in this case, what is FU? 890. 890 plus 45 is 935.2, 935 plus zero point 0.2 megahertz, where n represents the channel, number. Okay, so this is how the communication happens. That is, if the mobile phone is using this frequency to communicate with the base station, then the base station will use this frequency. If the mobile station is using this frequency, then the base station will be using this frequency to communicate back with the mobile station, right? So this is the overall working principle of FDMA. Okay, so what we have discussed in the sense, see there are two types of FDMA available. One is pure FDMA, the other one is which is not a pure FDMA. In case of pure FDMA, the frequencies were fixed and it will never change. That is, the station will permanently use that frequency for communication, but that technique commonly we cannot use for wireless networks, because in wireless networks the user is not going to communicate permanently. Whenever he want, then only he communicate. So we will not use will not go with fixed frequency option. Okay, so the another way of using FDMA is the frequency will change depending on some pattern. Okay. So that the pattern in which the frequency getting changed, so that is called as hopping sequence. The sender and the receiver should be synchronized with the hopping sequence. Again, this synchronization is also a little problematic. So whenever a hopping pattern is fixed, the particular station will use the hopping pattern for considerably a large amount of time. Okay, and then the communication from the base station to the mobile station, that communication is called as downlink, and the communication from the mobile station to the base station, that is called as uplink. Okay, and there are different frequencies for downlink and there are different frequencies for uplink, and generally the width of the each frequency each channel will be 200 kilohertz. So that's what about FDMA technique. So next we will be moving to the next medium access technique, which is time division multiple access. Okay. So compared to FDMA technique, time division multiple access provides much flexible scheme. Okay, because it includes all technologies that allocates certain time slots for communication. So why it is more flexible in the sense, now you need not to tune into certain frequency. Tuning into a certain frequency is not required. Now tuning is not required. The receiver can stay on the same frequency. There is only one frequency and the receiver can use the same frequency for the whole time. Okay. So using only one frequency is very simple for receivers and transmitters. And there are, we have many algorithms to control the medium access. So listening to different frequency and is little challenging, but here that problem is not there. Okay. So here the sender and the receiver must be synchronized based on time. Based on time domain, the sender and the receiver should be uh, synchronized. Okay, so so again this can be done using a fixed pattern uh, similar to FDM technique, that is that is by allocating a uh, certain fixed time slot for a channel, or by using dynamic allocation scheme. So like how in FDMA we have discussed that the frequency can be fixed for a particular user permanently. Similarly, but generally that is used with radio stations and that is not used with mobile stations. So similarly, when you go for TDMA also, you can say that this time slot will be always fixed for this particular user. Okay, that is called as a fixed TDMA. Or you can go for a dynamic TDMA where the time slot will not be fixed. Based on the demand, that time slots will be assigned for different users. So 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 that concept is called as fixed TDMA or dynamic TDMA. Okay, so okay, so so that's it about TDMA, time division multiple access. So the next topic that we'll be using is fixed TDM, fixed time division multiplexing. Already in the last topic we have discussed the time division multiple access can work in two ways. Either it can be a fixed TDMA or it can be a dynamic TDMA. So here let us discuss how the concept of fixed TDM works. So here the time slots are fixed. in certain pattern for various users, and the time slots are fixed for permanently. Okay, different time slots will be used for uplink and downlink using the same frequency because there is no change in the frequency. So let us try to understand with a diagram. So, so the base station uses uh, 12 slots for downlink, and mobile station also uses 12 slots for uplinks. Okay, 12 different mobile station uses the same frequency without interference because there is only one frequency, but there are different time slots. So let us see that particular diagram so that it will be clear. So here you can see uh, now the medium is not multiplexed based on frequency. We have only one frequency, and everybody will be using the same frequency, but the sender and the receiver were will be will be using different time slots. Okay, that is there is 12 time slots for downlink, that is for the communication from the base station to mobile station, and there is another 12 time slots for uplink, that is for the communication from the mobile station to the base station. Okay, so this will support up to 12 mobile station. This concept, this particular diagram, this typical example whatever it has shown, it will support up to 12 mobile stations. That is, the mobile station 1 will use the first time slot. Whenever he want to communicate something to the base station, he will communicate using this time slot. Similarly, if the mobile station want to send something, whenever the base station want to send something to the mobile station, it will use this time slot. Similarly, if the mobile station want to send something to the base station, it will use this time slot for the mobiles, for the first mobile station. Similarly, if the base station want to send something to the mobile station 2, it will use this time slot. Similarly, if the mobile station 2 wants to send something to the base station, it will use this time slot. Okay, so this is how this technique works. So actually this technique was used in DECT, digital enhanced cordless telecommunication, and the pattern is repeated for every 10 milliseconds. That is, this pattern will fastly it will repeat for this. This is something like how the processor context switches. So it context switch at a faster rate. So so it repeats at every 10 milliseconds. That is, each slot will get 4.7 microseconds for their communication. Okay, so each slots will get only 4.7 417 microsecond. Each slot will get only 417 microsecond for their communication. So this concept is fine for constant data rate. If the data rate is constant, that is for voice communication, but it is not efficient for bursty data, like for internet communication or for browsing communication. Okay, so and also it wastes a lot of bandwidth. It is too static and is not inflexible. Okay, these are some of the drawbacks with this technique. Okay, so this is how basically the fixed TDM concept works. Okay, so what we have discussed here in the sense, first we have discussed TDMA. So with TDMA, all the stations will be using the same frequencies, but they will be using but the time will be multiplexed. That is, different users will be using the channel at different time, and this can be of two times, either fixed TDM or dynamic TDM. In fixed TDM, the time slot will be fixed for a particular user. That is, that particular time slot will be used only by that user. Whereas in dynamic TDM, the time slot will vary depending on other parameters. So here we have discussed an example for a fixed TDM, how 12 devices can can work based on fixed TDM, and also we have discussed how it is used in DECT, digital enhanced cordless wireless communication. Okay, so let us stop here, and then we'll continue with classical aloha and other concepts in the next lecture. Okay, thank you.